Looks like we're good to go. If anyone has not completed that diagnostic, I pushed it out one more day. Please make sure that you do that. I have to turn in an attendance report on Friday, and we use that as a measure. I did try to send out an email if you had not completed it. So please do. Don't stress over it. Just take it. I would like to encourage those who have not done any homework yet to start, because you can't do all this right before the test. But I'm probably preaching to the choir because if you're here, you've probably done your homework. So we'll just go forward. I'll leave it at that. I did not get any requests, so I'll just go with what I picked. And we're going to start with 2.4b. And I'll have to pause a little bit now and then at the beginning to let more people in. So 2.4b is still solving quadratic equations. And this is a new technique for us. Unless you're told specifically to solve a quadratic equation with this method, I would not choose this method. A lot of times I will see students on a test choose to do this method to solve an equation. It's slower than the other techniques, but it has value in itself because later on we'll create equations of circles, and we'll do other things, and we will have to complete the square to do it. So we will learn to use it to solve a quadratic equation, but if you're not told to use this method to solve, I would not choose this method. All right, and I pulled up a handout I'm going to put up here first, and I'm going to tell you where to find it because it has other problems that I'm not going to do on it, worked out in detail. And in your Blackboard shell, it is under Content and Handouts, and then Complete the Square. So I'm just going to pull it up so I don't have to write the rules with this little small thing I have to write with. All right, so from 2.5, 7 through 14. All right. And so that would be 2.5a. Sarah?
Yes. Yes.
Okay.
I'm sorry, I wrote them on a piece of paper, and now that I see it probably wasn't smart.
That's okay, no problem. We actually, we will get just to one or two of those at the end.
Okay.
And then we'll come back to more of them next time.
Perfect. Thank you.
You're welcome. And please ask me anytime. If you send me an email, I'll have them set up. So we'll do them first.
Perfect.
All right. So these are our rules, and I'm just going to read them. But you can pull them up in that handout and you'll have them. You won't have to write them. So first of all, you want to go to standard form. And if your leading coefficient is not 1, you need to divide it out, right, so that it will be 1. And you have to do every term on both sides. Then you're going to isolate your variable terms on one side. And you have to move the constant to the other side. Then you're going to find what I call the magic number, step 3. And the formula for that is to take half of the coefficient of the x term. So what was your middle term, you're going to take half of that coefficient, and then you are going to square it and add it to both sides of the equation. What this is going to do, it's going to force that left-hand side to become a perfect square trinomial, which will be 2 parentheses when they're factored that are just alike. And once you have that, you can solve it with the square root method. So those are our steps, and I'll mention them again as we go. So let's see if I can get to the edge of this and turn it off. So that is under content and handouts. I think I have a couple in there. All right, and so I started us off with problem 4. The first couple just have you choose the number. We're going to go ahead and do one that will go farther than that. And so this one tells us to look at this quadratic, and they're going to force us to complete the square. And they want to know what number we have to add to both sides. So they're looking for the magic number. All right, so let me write it. It already has the first step completed because our leading coefficient is a 1. So we're good there. We don't have to divide anything. Step 2 says get your z terms on the same side. They are constants on the other side, so we're good there. Your third step is to find this number, which is what they want for our first answer. So you always take a half of your coefficient of b, so half of 14 is 7, square it. That gives us 49, and you're going to add that to both sides. So just going to scoot this over a little bit. And I'm adding 49. And then I will factor on the left-hand side. We have forced it to become a perfect square trinomial by what we added. And it will always factor to 2 parentheses that are just alike, like signs both plus. And it will pick up every time this first piece, our 7. But you can go through the steps if you don't remember that. So you multiply to get 49, add to get 14. Right, and the other side, we'll work that out. So it's 5, 25. All right, so I'm going to put this in a square form because that, when it looks like that, it makes us think of the square root method. All right, so we're going to do square root of both sides. And I'll take one more step to do it. So if somebody looks at it later, they will know what I did. Remember, when you do square root of both sides, you get plus and minus. That side. This side is going to eliminate the exponent. So you get z plus 7 equals 25 is a perfect square. So plus or minus 5. And now you have to isolate z. So you're going to subtract 7 from both sides. Put it in front of the plus and minus so that it picks up both of those.
Professor?
Yes.
When I was entering answers into the software, I noticed sometimes I'd have to write them in a very specific way, especially for these problems. I was wondering, is this how it's going to have to be entered every time? So you do the minus 7, plus 5, comma, minus 7, minus 5, or you don't do the plus? Because I couldn't figure it out.
It is accepting that answer. If it was a paper test, I would not accept that answer. I would want you to go one more step. So there might be some questions that are programmed not to accept this. And the reason is because they're plain numbers.
Mm-hmm.
So I would go ahead and work them out. Now, if you get a radical or an I, then you would not. So I would just go first with the plus and work it out. So -7 plus 5, and that would give me -2, and -7 minus 5 would give me -12. So the software really should not accept it here. It should count it wrong, but I did see that it was accepting that in some cases.
Because it seemed to be very intermittent for which ones it accepted and which ones it didn't.
Okay, so sometimes it didn't accept it that way.
Yes, but it seemed to be like kind of a 50-50 split.
Okay. And I'll ask our guy who programmed these, because Dr. Kilman wrote all these questions. I'll talk to him about that. If I get to other pieces that it seemed to enter funny for you, please ask me again, because there'll be some that look different than this one. And I would like to come back to that if we do. All right, so I'm going to enter these instead of just anytime there is any kind of question like that, I will enter them instead of taking the shortcut and looking at the key. So first answer is this number that we found, the 49, that has to be added to both sides. And the second one is our answer for Z. And I would want you to have -12 and -2. It should never mark that wrong.
Quick question.
Yes.
Do you want, for us to find the constant, do you want us to do it, is this an easier way rather than doing the 2x equals 2 times x times c?
I haven't ever heard that way.
Oh, it was in one of the videos. That was how I was finding the constant when I was doing it earlier.
Run that by me again one more time.
2x equals, oh, this was from a different problem. Oh, no, that's right. So 2x equals 2 times x times c.
I think this is much faster myself.
Yeah. Yeah, that's what I was going to ask.
Yeah.
Perfect, thank you.
I think this one is much faster.
Okay.
So it's because it's always this pattern. It's a half times your coefficient of b once you're in the proper form, and then square it.
Okay, perfect. Yeah, because that would make every single one that you do an even, like this, make it even. I understand.
Now,
it sounds like I don't, but I do.
We'll get one problem near the end of these where you end up still with a fraction. And we'll go through that and see what to do, but you would still do the same pattern. All right. Let's see. I did pick number 5. And when you do these, you'll get different numbers in these than I have. Probably. Okay, most of the time, because they are randomly generated. Right, so we have z squared minus 2z equals 17. And they're telling us that we need to go this route. So we'll make sure we have the first 2 steps covered. Our leading coefficient is a 1, so nothing to divide out. Also, we only have the z terms on one side, so we're good. So we're going to take a half times the coefficient of what would be the middle term, so the b. So half times -2 gives us -1. Square it. And 1 is what we're going to add to both sides to make a perfect square trinomial. So left is going to factor to 2 parentheses just alike. Like signs both minus, and it is going to use ones. And we'll just go ahead and write that as z minus 1 squared equals 18. And now we're ready for the square root of both sides. And I think I'm just going to go ahead and do it on this. At least it's a color change so you can tell. All right, so this one will cancel out. Z minus 1 equals plus or minus square root of 18. So let's see if we can simplify that on the side. 18 is a perfect square. Sorry, it has a perfect square in it. It has a 9. So I usually break it down to primes. But if there is a perfect square in it, it's not simplified. That's a 2. All right, so we can take 1 3 out. The 3 will need to be right against the radical, and the 2 will stay underneath. Now we need to isolate our z, and we're going to add 1. I would put it in front of the plus and minus. Sometimes when you look under the answer key, which you guys don't have, but it does show it after, you have the issue of if you have not moved out from under that radical, it will think that it's under it. So I would never put it after. I would always put it in front of the plus and minus, and then you have to split those. So we have 1 plus 3 square root of 2 and 1 minus 3 square root of 2. And we'll look at the answers here. This is 1. That is our number that we added to both sides. So this is our first answer, right? And let's see where they put them in the key. They put the 1 after. The trouble if you try to do that is when you finish your radical, click at the end and move out from under it. If you put it in front, you're safer. I'm going to go ahead and type it. And I'll type this first one in too so that you can see what it marks, right or wrong. All right, so I'm going to type it with the 1 in front. Now, even for the comma, I have to come back out from under that radical. So use your arrow on the keyboard or click at the end, either one. So I used the keyboard for that one and a comma, and it probably will say syntax error if you don't. And the other one is 1 minus 3 square root of 2. I would even click on that one. So it liked those answers. But it would have accepted as long as you clicked at the end of the radical. Then if you put the plus 1, and here it would also be plus 1. This minus sign is with the 3. Okay.
Quick question.
Yes.
So I guess from that example, it doesn't matter, I guess, where you put it, in the front or the back, but we're going to put it in the front. Would it make a difference? Just because, like, if, like, 2 minus 1 compared to 1 minus 2 are 2 completely different answers. It's not like that with the rad.
It's not going to combine with the radical.
Okay.
So, and you just have to have the right sign with the right piece, though. If you wrote it the other way, you have to have plus 1 after, because this minus is with the 3. It is not with the 1.
Okay, thank you.
So if you had put it after, both of those need to have plus. So I think you're safer to put it in the front. That is just me. And that's standard what you see in writing. Because most things will let you get away with just leaving the plus and the minus. Most things would let you leave it right here on a paper test, which you guys don't have a paper test. But if you go higher, you may have a class that does, and this is an acceptable answer. So it could be left with that. Any other question here? Right. Next, I picked number 7. And I try to pick ones where different things show up. And this one, the order is the issue. And they're just telling us now to complete the square. We don't have to show the number that we're adding to both sides. It does have a leading coefficient of 1, so we don't have to divide out. But the trouble is the 16 should be on the other side, and the 18x should be on this side. The x terms should be on the same side, so we're going to move that around. So we'll add 18x to move this one. And I'm going to just leave a little space there, and I'm going to add 16 to get the other one to move. Now I'm ready to perform my complete this square steps. So half times 18 is 9, and 9 squared is 81. So that's what I'm going to add to both sides. Right, so left-hand side is going to factor, and it's going to pick up the 9. And this side will add 97. And so this will write in our square form. You would want to think about the 97, would it break down? Because we're going to take the square root. We'll go ahead and do the square root first. So x plus 9 equals. Thinking of 97, okay, first of all, it's not even, so you're kicking out all of your even ones. They're not going to go into it. It doesn't end in an even digit. The other one I would just test, quick divisibility test. If 3 goes into something, if you add these digits, so 9 plus 7 is 16. If 3 goes into 16, it will go into 97. So it does not. So I'm thinking that that one does not simplify. I could test it on my calculator. And this calculator is going to switch me to a decimal. So you can scratch that mark about calculator. There are some scientific calculators that will show you whether it's simplified or not.
My calculator just shows square 97.
Okay. And you probably have, what kind do you have?
I got the Casio FX 300.
Okay. So it's showing you that it's simplified. So saving that step. And if it wasn't, it would simplify it more. So we'll leave it there. I'm not going to go through trying to run through the primes. Right, and we still have to solve. So we're going to have to subtract 9 from both sides. And I'm going to do it in front of the plus and minus. Sub x equals negative 9 plus or minus square root of 97. And we can look here. And this time it put it in that order. It would accept it as long as you have the signs exactly right the other way, I believe. But put it in front. Any questions on this one?
Professor, I have a question.
Yes.
Okay, when we get the third number, so let's say it's plus 81, is that number always going to be a positive?
Yes, because you're squaring the thing before, because sometimes this one will be negative, and when you square it, it will become positive. So the number that you're adding to both sides will always be positive.
Thank you.
You're welcome. All right. Let's see. So we're good there. I'm not going to type it. So I'm going to go to question 9. And this is one that is not so nice. Looks like it'll be nice. I mean, it's nice small numbers. And it has the first step is okay. Your leading coefficient is 1. You need to get the x terms by themselves. So I have x squared plus 9x. And I'm going to add that 3 to both sides. Right? And now I have to find my magic number. And because this is not an even number, when I take a half of it, it's going to leave me a fraction. So 9/2. That's okay, I can do it. So I'm going to have 9/2 and I have to square it. And your exponent will go to each one. So I have 81/4. That is what I'm going to have to add to both sides. Let me move that over a little bit. So I'm going to add 81/4 and 81/4. Now, on your left-hand side, it's still going to factor and pick up this piece you found in the first half of that magic number step. So it's going to factor with 9/2. And the other side, we're going to have to do some work. So however you are with fractions, you can do it on your calculator. You can do 3 plus 81/4 is 3 and 81/4 and change it to an improper fraction. Or you can do it by hand and get a common denominator. So I think I will start with, I'll just do it by hand, right? So I needed 4 underneath here. So what I have 3/1, and I want to get a 4. So I'm going to have to multiply by 4/4. That will give me 12/4, which is equal to 3. So I have 12/4 plus 81/4, which is giving me 93/4. So x plus 9/2 squared equals 93/4. So I'm going to do the square root of both sides. This side will take your exponent off. This side, I'm going to go a little bit more out here. So my radical will go with the numerator and with the denominator. My denominator is a perfect square, so I can put that much back. And 93, I'm going to try to clean up. Square root of 4 is 2, right? I know that something will go into 93 because if I add those, 9 plus 3 is 12. So I know a 3 goes in there. So just on this side, I'm going to try to break 93 down. And 3 will go in there 31 times. So it's actually not going to break down, but I knew it had a 3 in it because 3 and 31 are both prime. So it's going to stay like that. I need to get my plus and minus back on there. And so now I'm going to subtract 9/2. So I'm going to do minus 9/2 in front of this. And I believe you could put them in with it separate. I did notice in the answers, it put them together as one piece. So said your denominator is the same, so keep it and combine the numerators. So negative 9 plus square root of 93 over 2, and negative 9 minus square root of 93 over 2. I think this would also be acceptable without actually putting them together. So it put them together. Any question on this one? This one had a lot of little details where you have to watch out. And if you have a hard time with fractions, make sure that you could do them on your calculator. I can show you on the graphing calculator. And the graphing calculator is not as nice as some of the scientific ones. Your Casio that you have will do these fractions even nicer. So if I do 3 plus, and this calculator does not have a fraction button, so I need to keep the entire fraction together, and so parentheses is your friend there. So 81 divided by 4, that is holding it all together. Right? And enter is going to give me a decimal. They don't want a decimal, so to get back to a fraction form on this calculator, and most graphing calculators would be the same, you go under the math menu, and your first choice moves it back to a fraction. So we hit enter, and we hit enter one more time. And there is your answer on that. So you can do the fraction math on your calculator, or you can do it by hand. I know that there will be times in your future if you go higher in math. I know in pre-calc, there was a place we were doing matrices and there were fractions just everywhere. And it was too slow to do them by hand, but it was very fast to do them on the calculator. So you will come to that point sometimes when that is faster. All right. I think I had just one more of these. Actually, I had two, I think. All right, so number 10. Number 10 is going to pull in a number in the front. And as long as this divides out evenly, then it's easy. If it doesn't, you're going to get fractions like the problem we just had, but you're able to work with them. I think the others in these work out evenly. So it was just problem 9 you have to watch out for. All right, so first step is we have to get rid of that 4. So divide everything by 4. So 4 into 8 will go 2, and 4 into 12 will go 3. Right, and it's already set up. It has the y terms on one side. So we're going to do half times 2 is 1, square it, and that will still be 1. So that is what we're adding to both sides. And left-hand side, we'll factor, it's picking up your 1. So we have y plus 1 squared equals 4. And now we'll take the square root of both sides. Don't forget you get plus and minus. This will get your exponent off. So I have y plus 1 equals plus and minus square root of 4. Square root of 4 is a perfect square, so it is a 2. So you need to subtract 1 from both sides. So y equals negative 1 plus or minus 2. This is one I would want you to work out because it has plain numbers here. So we can do negative 1 plus 2 is 1. And we can do negative 1 minus 2 is negative 3. So negative 3 and 1. There we go. And it wouldn't really care about the order. That's a nicer order in numerical order. Any question on this one? This one's a lot easier than the one we just did. All right, and I have one more. Let's see, I went to 14. All right, so this one has a leading coefficient of 1, so that's good. We need to get the x terms on the same side and nothing else over here. So we're going to move that 17, so it'll be minus 17 over here. We're going to take a half times 2, which is 1, square it, and it's still 1. So we're going to add 1 to both sides. This will factor. And over here you have negative. So you're going to do your square root of both sides. And if you have a negative under the radical, what kind of answers are you going to get?
I.
An I, exactly. And the 16 is a perfect square. So this is going to be plus or minus 4i. Right, so I still need to move my 1, so I'm going to subtract 1. So x will equal negative 1 plus or minus 4i. And you would have to separate it because there's no plus or minus button. So this one wasn't so bad. It just gave you something a little different. All right, I'm going to switch over to the next section. And we probably won't get to the end of this section, which I had planned for it to be 2 days. So we will finish whatever we don't get done next time on this section. Get a new page here, and this one I have to get a new section. And the first one in this, the first few in this section, so we're in 2.5a, are polynomial equations. So they can have an exponent higher than 1, but I'm sorry, higher than 2, but really the only way we know how to solve those is to factor. If we can't get it down to a quadratic, we don't have a nice formula to solve it. So we'll keep that in mind as we go. So I did pick number 1. So we'll be testing some of your factoring skills in this. I would move everything to one side and 0 on the other. And see, this is q to the 6th. So we don't have any formula for that. It is an equation. And it could get up to 6 answers, right? Whatever the highest exponent is, it could get that many. All right, so what we'll do is factor. There is a GCF here. So we can take out a 2 and a q to the 4th. Right? And that is going to leave us a q squared minus 2 goes into 8 4 times. And this will factor some more. This is a difference of squares. So that will be q plus 2, q minus 2 equals 0. So now we can use the zero product law. We have 0 on one side. We can set each of these pieces of the product equal to 0. You can keep your constant with this. So 2q to the 4th equals 0. That one you're just going to divide by 2, and it's going to be 0. This one, q plus 2 equals 0. Q will be negative 2. And this one, q minus 2 equals 0. Q will be 2. So we have 3 answers. I will just put them in numerical order. We didn't get 6. We could get up to 6. All right.
Question, with the test, one of the other videos that I watched, it showed that the q to the 4, like, technically is like multiple, is technically 4 zeros. Would there ever be like any tests that would make us put that in?
No.
Like that's technically you know what I'm talking about? That it's like that 0 counts as more than 1, I guess.
When we go into a couple of chapters from now, we will look at things which have what we call a multiple root. And this q to the 4th is one. When you do the graph, it is going to do different things there. It will bounce off of that 0 line. And it's when it's a multiple root, you get things like that in graphs. You get weird things. So it won't cross as many times when you put it in your calculator.
Okay,
So
thank you.
Remind me when we get there, we'll come back to that. But you would never need to show that as just part of the solution because we're just getting the answers for it. Right. Next I picked question 3. And it is an equation. It has an exponent of 3. You need to get all the terms on that same side. And then this one will be a grouping for your factoring. So I have to add 21 to get it over here. So hopefully you remember grouping. And so we can take out an x squared, and that leaves x minus 7. Here we'll have to take out a negative, because it starts with negative 3. And that will leave x minus 7, because the negative, if it goes outside the parentheses, it came out of both. And what you hope to get is a common binomial, which we did. So that is now our GCF. And we pick up x squared minus 3. Now, this one will not keep factoring because the 3 is not a perfect square. So we'll work with it like this. Since it's down to the exponent of 2, we'll be able to solve it with a different technique. So for the first one, we just said x minus 7 equals 0, and that one is x equals 7. And this one, though, when you set it equal to 0, you have to think back to your quadratic equations, what you would use to solve it. And this one is a good setup for square root method because it doesn't have a plain x term. So add your 3 to the other side, and then you can take the square root. So x will equal plus or minus square root of 3. So we did get 3 answers on this one. So we have 7, we have negative square root of 3, and we have positive square root of 3. Is that one okay? right, next I picked question 5. This one kind of made me cringe when I looked at it because of the numbers, but they work out okay. All right, and so it's to the 3rd power, so we have to try to do some factoring. Grouping is your choice when you have 4 terms. So we'll try to group here. And the only common thing we have in this first group is the variable. So we can take out an x squared, and that leaves a 6x minus 7. And for this group, I believe there is a 25 in there, in both of those. You know you want to get a 6, so if you don't think of the 25, you can divide this by 6. And so it is 25, I believe, that is your GCF there. So it has to go into both 150 and 175. So it goes 6, and it's going to go into the other one also. It'll go 7. So 25 is our common factor, and that leaves us 6x, and it will be minus, and it will go 7. So 175 divided by the 25 is 7. So we did get the factors that match. We'll pick up the missing pieces. This will not factor more. It's squares, but it's plus. And that one won't factor more, so we'll have to solve it with the square root method. This one we can set equal to 0. It's just going to be 2 steps of solving. You're going to add your 7 and divide by 6. So 7/6 is that answer. This one, because it doesn't have a plain x term, square root method is nice. So we'll move the 25 to the other side. Take the square root of both sides. And this one, because it's negative under the radical, is going to give you an I. So this will be x is equal to plus or minus. 25 is a perfect square, so it's common to just write that 5i. It should accept it if you write I and 5 because they're multiplied, but this is standard. All right, so you have 3 answers, 7/6 plus 5i and minus 5i.
Would we ever have to pull out the 1 from the 7/6?
No.
Okay.
In algebra, we would rather have an improper fraction because it's only one piece.
Okay.
The only times I can think of, and that's not anything we're going to have right here, but if you're just graphing something and you're looking for a point, then it's much easier to switch that over than to cut it all into sixths. So that's a place, if you're solving percent problems, they will also tend to switch that back to a mixed number. So 1 1/6. But most things in algebra, they would rather leave it.
Okay, thank you.
You're welcome. We'll just enter this one. So 5i and negative 5i. And it doesn't matter if you do I from the keyboard or from the template. Good. I did choose 6. There must be something else that happens on this one. And the first thing is I would move the 24m squared to the other side. You want to keep your leading coefficient positive. And then I would factor out a 3m squared. And that's going to leave me m cubed minus 8. And then you can set each piece equal to 0. This will factor more, this m cubed minus 8. So let's go ahead and factor it. If you remember difference or sum of cubes, you take the cube root of each of these pieces. They have to be perfect cubes, otherwise it won't work. So that is an m and a 2. The first parentheses uses those pieces with the sign of the problem. The second set will be a trinomial. Its signs, you'll have opposite sign, and left one is always plus. You're going to take the first one times itself, so m times m is m squared. First one times the second one, m times 2 is 2m. And last one times itself, 2 times 2 is 4. When you factor a cube, this piece will not continue to factor. And it is still a quadratic, so that piece of it will have to go to quadratic formula to solve. These two we can solve. This one's just going to be 0. So you divide by your 3, but it's going to be 0. This one is going to be 2. But this one, we know it won't factor more, so it has to go to quadratic formula. Looks like it would do more. All right, so my A is 1, my B is 2, and my C is 4. So X is equal to, or M is equal to negative B plus or minus square root B squared minus 4AC all over 2A. So my B is 2, so I'm going to go up a little bit just so I can have more room. Negative 2 plus or minus the square root of 2 squared minus 4 times A, which is 1, times C, which is 4, all over 2 times 1, which will give me 2. So I'm going to clean up some more. So negative 2 plus or minus, under the radical 2 squared is 4. I check my signs here. It's going to be minus, and this 4 times 1 is 4 times 4 is 16. This one's going to have I in it. So 4 minus 16 is going to give me negative 12 under the radical. So the I is going to come out, but also you have to simplify the square root of 12. 12 has a 4 in it. So if you break down, and 4 is a perfect square. So 2 times 2 times 3. A 2 can go out. So we're going to have a 2, an I, and the square root of 3 is left. So I have negative 2 plus or minus 2I times the square root of 3 over 2. And it's going to make you work a little bit more. Because around this plus and minus in that triangle, you have a common factor. So you have to divide it out. So this will give us negative 1, which you do have to write that negative 1, plus or minus. This will be I left, so you don't have to write that 1. And this 2 divided out. So we have these two answers. We also have 2 and 0. So altogether we have 0, we have 2, we have negative 1 plus I square root of 3, and we have negative 1 minus I square root of 3. So that one had a lot of work that you had to remember. Questions there?
So if there's ever a a polynomial, we have to end up using the quadratic equation then? Like
If there is one that won't factor, you will.
okay.
Yes. And anytime it comes out of a cube, it won't factor. All right. It's kind of moving now into the other type of question, but I want to do for you, I'm going to first go to 8, and then I'll backtrack to 7, because 7 will have to do the new method. But 8, you don't have to on this problem. And it just depends on what numbers you get when it comes up. This one, you might be able to see what would work to make this one factor. Because you can multiply to get 39 and add to get 16. If you think of 13 and 3, 13 times 3. So this one you could work, and just here you have to guess what would be the square root of y to the 4th, and you would probably guess y squared. This would be like signs both minus, and it was 13 times 3. And they're both going to have minus, and that does give you 16. All right, and then we have to solve these. So when we set it equal to 0, well, we're going to need to use square root method here. There's no plain y, so you're going to move your 13. Then you take your square roots. And this one, move your 3 and do the square root. So we actually have 4 answers, and we are allowed to get 4 answers because the exponent is 4, the highest exponent. So I want to backtrack to 7, because when I pulled these up, and when I pulled it up before, that didn't happen. 7 was one I could work like this. But this one, this will move us into the other method that's used in this. And it's when you have things that look like quadratic form, but we do what's called a U substitution. So we have z to the 4th plus 6z squared minus 91 equals 0. So the 91, I don't see anything that would factor. I mean, maybe I could have factored it. I don't know. It doesn't look to me like anything that would factor. So what we'll do is what we call a U substitution. It does look like something in quadratic form, and you have to pick out what you're going to let your U be, and it is from your middle term. It's where you're going to get it. So we're going to say U is z squared. Now we have to check and make sure that this one would be the square of that. So we want to look and find U squared. So we just look at what we picked here. Z squared squared is z to the 4th. That has to check, which it does. So we're going to change, and instead of working that problem, we're going to put these u's in. So this is u squared plus 6u minus 91 equals 0. And a lot of times at this point, you can factor, but the 91 doesn't play nice. And so we'll go to quadratic formula. So our A is 1, our B is 6, our C is, our B is 6. Boy, those 6's and B's look a lot alike. Our C is negative 91. All right, so our U is equal to negative B. I'm going to just fill this in instead of writing the formula. So U is equal to negative B, so negative 6, plus or minus the square root of B squared, I will write that much, minus 4 times A times C all over 2 times A. Right? And so negative 6 plus or minus 6 squared is 36. And here you have 2 negatives. And this will do 4 times 91 will be 364. And this is all over 2. And so this is going to give us 400. And 400 is a perfect square. I believe the square root is 20. It is 20. So you need to work this on out. You could actually divide the 2 here and then do them, or you could do negative 6 plus 20 divided by 2. So I have negative 3 plus or minus 10. I did that. So this will be 7 with the plus, negative 3 plus 10. I'm getting a 7, and negative 3 minus 10 is negative 13. So this probably would have factored. Now, you're not done here, because whenever you do a U substitution, you have to substitute back. So I have to go back to the beginning because I don't want to know U, and that's what I have here. These are U. I want to know Z. So U is equal to Z squared. So this, I have U equals these. So instead, I'm going to have to do, put Z squared here. Z squared equals 7, and Z squared equals negative 13. And then I have to finish solving those because I want to know Z, not U. Right, so square root method here. So Z equals plus or minus square root of 7, and Z equals plus or minus square root of negative 13, which is going to have an I outside. 13 is going to stay. So our answers, there's 4 answers, plus and minus square root of 7, and plus and minus I times the square root of 13. And you notice they have the I at the end. You have to be cautious if you enter it there, and make sure you have moved out from under the radical. So click at the end of the radical, then you can type it or use the arrow. Or if you put it in front, you're always safe. All right. I think that I better stop there. This one is just giving you a glimpse into the rest of the problems. And I'm sorry, Sarah, that I didn't get farther. But I will do those next time.
No, it's okay. Thank you so much. That was a huge help.
You're welcome. All right. So we'll stop there. You guys have an awesome day. And I mean, we're moving on up. This is a little harder level.
Thank you, Professor.
You are welcome. I'm going to turn off the recording if anybody else has questions.